Hello, CS251 students. The purpose of this video is to prepare you for your next lab and get you doing a little bit of assembly language programming using a product called Mars. And if you go to the Canvas homepage, if you go to Helpful Resources, you will see there's a link there to Mars. If you click on that, you will shortly be in Mars. And let's see, you will want to click here where it says Download. And you can also, of course, do this in Windows. I'm going to show you how to download in Windows in case that was a surprise. I'll click here and it could harm your device. No, it won't. And I'm going to click on Keep. The product that I get here, now this actually should be installed on the machines in 101C, but I realize that most of you will want to probably do this on your own computer. This is a freestanding package. I don't think it requires much. I'm just going to, let's see. Let me just open up the folder that it's in and let me double click on it. And in a moment, we will be looking at Mars, not the planet, the program. Now, let's see, this thing is jumping up and down at me, that's fine. So this is Mars. This is a program that you can use to write MIPS programs. The first thing we're going to do is go under File and choose New. And now we have a file. It's temporarily called mips1.asm. We can do all sorts of things here. We're just going to do the very basics. So we're just going to say .text. And this means that what follows here is going to be interpreted as assembly language programming. And it's going to be stored in a particular area of memory that we will talk about later. And you can start issuing commands. So for example, you could say add T0, and actually let's do this. Let's do T0. And you should recall that this is going to take the contents of T0 plus T1 and put it back into T0. We could do another statement, add T1 and 0 and what's your favorite number? 37, you say? Very good. So this takes the contents of the register 0 plus the immediate value 37. And so 0 plus 37, of course, is 37, and it stores it in T1. You can do other things. If you just want to get a number into a register, the easiest instruction to use is called LI, and that's no lie. It's LI, load immediate. And so, for example, you could say into T0, you want to put the number 42. And as a result of executing this, 42 will be in the register T0. So it's just a series of statements. At the end of every program, you have to behave nicely. And so you have to make a system call. To make a system call, you load into a register called V0 a particular value. To bail out of a program, the system call you want is number 10. And so we'll just say that, and then we make the system call, and that's how you should end every program. It basically returns control to the quote-unquote operating system. Now, having done this, we should go ahead and save it. If we don't, if we try and run it, it won't let us assemble it yet because we haven't saved it. So let's go ahead and save it. And I'm just going to call it lab.whatever.asm. And I will save that. And now, so this is assembly language, and we have to turn assembly language actually into machine code, and that's what the assemble command does. So if we do assemble, you'll notice that it now shows us in the text segment, we have a series of statements. I hope when I zoom, I don't know if I zoom in if this will work or not, but hopefully just get closer to the screen and you'll be able to see this for sure. There's our first instruction, LI T042. By the way, we said that every one of these assembly language instructions actually has an underlying numeric value with an opcode and some operands. Here's the numeric value. Would you like to program by writing 2408002A, or would you rather write LI T042? I suspect all of you said the latter. Anyway, these instructions you can now execute. There's a run button right here, and there's a step button. So this executes one line at a time. Over here on the right-hand side, you can see all the registers. And we're really interested well, let's start off with this first one, LI T042. So notice that T0 right now is 0. Watch closely. Notice it turned green, and it contains the value 2a, hex, and that is in decimal, of course, 2 times 16 plus 10. 32 plus 10 is 42. The next instruction says take the contents of T0, which is 42, and T1, which is currently 0, add them together and put it into T0. So actually, T0 is not going to change as a result of this. It's sort of boring. The next instruction says take 0, the contents of register 0, which is 0, plus 37, and add it and store it in T1. So now when we do this, T1 is now 25, which of course is 2 times 16, 32 plus 5, 37. That's the end of the program. That was extremely exciting. So now we just go to here, and we go to here, and the program is done. When you want to quit, you choose exit. So that's how you can use Mars. Now, how does that relate to this lab? Well, this lab looks like this. It's MIPS Magic. And just zoom in a little bit here. So you're going to use the Mars simulator that we just saw. And again, you can download that from Canvas under the helpful resources. Let me again point that out. Let's see, home. Under helpful resources, just look for Mars. And let's jump back to our Windows, actually let's go back to the lab here. And what are you going to do here? Well, first you're going to launch Mars, you're going to make a new file, you're going to call it lab7.asm. You are going to write the first 7 Fibonacci numbers, known as T1 through T7. Now you know a Fibonacci number. A Fibonacci number is the sum of the previous 2 in a sequence. The Fibonacci numbers, each Fibonacci number is a sum of the previous 3. So for example, T1 is 1, T2 is 1, T3 is 2. And then for all the rest of them, for example, if I is 4, T4 is T3 plus T2 plus T1. And then T5 is going to be T4 plus T3 plus T2. Now, there is no instruction that will add 3 registers at a time. You can't do add ti minus 1, comma, ti minus 2, comma, ti minus 3. You can only add 2 elements at a time. So you're going to have to sort of combine addition statements to make this all work. The only registers you can use are $0, $T1 through $T7. I think at this point I'm going to stop saying the $sign because it just sort of gets in the way. Anyway, you're going to use add I to initialize T1 and T2. You're going to use LI to initialize T3, and add will be used to calculate the rest of the sequence. And you're going to be calculating again TI. So by the time you are finished, when I look in MIPS, I'm going to see that T0 right over here is going to be 1. T1 will be 1. T2 will be 1. T3 will be 2. T4 will be, I can do this, 2 plus 1 plus 1 is going to be 4. And then T5 is going to be 4 plus whatever the previous 3 were, maybe 2 and 1. Anyway, that's what you're going to have to do for this lab. I hope this makes sense. If not, we'll talk about it on Monday. Oh, we didn't talk about comments. That is one thing that I should mention. As you know, I'm big on comments. Let's hop back here. Now, if I need to get back to the code, I'm in the Executes tab. I can get back to Edit. And we should have a comment block here. So we can simply say name, your name here. You know the drill. Date. Let's see, description. This will be Lab7. Bugs, none that I know of, or if you do know of some, please let me know. And reflection. Please let me know what you thought about this lab. Too hard, too easy, too vertical, whatever. Anyway, and if you want to really gussy this up, ooh, look at that. Now this looks really professional. All right, that's it for this video. I will go ahead and post this. If you have questions about it, we are not going to be having class on Friday. I will, in fact, be going to this conference. And so take advantage of this time to work on this lab, and I will see all of you again on Monday.